Hello and welcome to the KIM-1 Corner series. In this series we'll be building various add-on boards for the KIM-1. So in this episode we're going to see if we can add a serial port to the KIM-1 so we can connect it direct to a terminal emulator on a PC. So here we have the teletype interface on the KIM-1. And if we look at the top where the printer is, we've got supply through a 150 ohm resistor. It's called printer return for some reason, but that's a current limited supply coming out. And that feeds through to wherever printer's been connected and gets switched by the teletype data out to make the current go on and off. So you get switched to 0 volts, and every time that's connected to 0 volts you get up to 33 milliamps flowing because it's a 150 ohm resistor, but there will be some resistance on the printer as well, so it's meant to be 20 milliamps. Now if we look at the keyboard side of it, that says keyboard return even though it's a current limited supply. That goes out to the teletype keyboard and that will switch the signal coming back in. It pulses it. Same as like serial does, but it's pulsing the current through. And the input has actually got a 220 ohm resistor there. So it generates a voltage across that 220 ohm resistor, which triggers the teletype data in. Now just below that, we've got this connection. We have to connect this up so that the KIM-1 knows that we're going to be using teletype rather than the onboard keyboard. It does that by connecting column A of the onboard keyboard to row 3. You may remember me mentioning row 3 when trying to work out a scanning before. I wasn't sure what it was for. Well, it's for scanning this input to tell whether we should use the serial input instead of the actual keyboard. This is the circuit they show you in the manual. It's a bit messy for want of another word. It makes you think the currents and voltages are flowing in different directions to what they actually are. So if we cut this down to make it a bit simpler, we have just this. This is for the printer. And the printer output, the U26 at the bottom, is actually an open collector output on the IC. So you've effectively got this transistor sitting there. Now we've got the supply, comes through from the top, through the current limiting resistor, goes out to the external printer, then comes back in to the actual printer port where it is switched through this transistor. So that transistor will be either not conducting, so you've got 5 volts sitting at AS and there's no current flowing through the loop, or it is conducting and pulling it down to 0 volts. So you'll have 0 volts at AS. But you will have current flowing through the loop. And what we want to do is we want to add this serial to USB adapter. Now instead of using the onboard 5 volts, I thought I'd use the 5 volts that actually comes on the small adapter. And we don't need to pass as much current, we just need to generate a voltage on the RX input to the USB adapter. A 1K resistor there or something similar would do. Bigger resistor will be fine. So at this point in time, we'll have 5 volts going through the resistor into the RX input, holding the input up. If the printer output from the KIM-1 was to turn on, we'd get current flow through the loop like this. And the voltage at the RX pin will be switched down to 0 volts, giving a 0 there instead of 5 volts. So as the output from the KIM turns on and off, the signal will pulse on and off at the RX pin. It's switching between 0 and 5 volts. You may not know this, but USB has got 0 to 5 volts on it as the supply, but the actual components and devices on USB run at 3.3 volts. I checked the datasheet on this and the input is 5 volt tolerant here, so we're okay to be switching 5 volts. So that will be coming into that pin there. So if we look at the keyboard now, we go back to the circuit, we just need this part of it. So at the top, we've got the 5 volt supply going out, again through a current limiting resistor. That will go through whatever circuitry on the keyboard, And we'll switch the signal back into AT, which goes through this 220 ohm resistor. And with the right amount of current flow, you will generate a voltage across there, which should turn on Q7. So if Q7 turns on, the supply is then switched down through Q7 through R17. Now, before that's switched on, if I can take that back, before that's switched on, we had 5 volts sitting at pin 12 of U15. When it switches on, like this, we'll effectively have 0 volts there. So you're switching the voltage on U15 on and off. So we have between 0 and 5 volts there. So we need to duplicate that with this to USB port. Now we have to watch out for the capacitor at the bottom that's 330 nanofarads. That will take current to switch that on and off, and it will limit the baud rate through here. I'm not quite sure what I got it for, probably just for noise immunity. And CR5 is probably there for a reverse voltage protection, because normally you're switching through the keyboard, which the teletypes might have had inductive loads on them, and it would cause negative spikes. So that bit of a protection diode there, which won't affect us at all. If we want to connect the USB to serial adapter in, we'll take the transmit pin from that, and we feed that into the keyboard input. And hopefully we'll get enough current flowing through there, through R47, to bring the voltage high enough to switch on Q7. So again, we've got to go for that 220 ohm resistor at 330 nanofarads, but we're only getting 3.3 volts coming out, because I mentioned earlier, USB only works at 3.3 volts. So that'll be about 15 milliamp. Hopefully that output can supply 15 milliamp. And if it does, it will then switch that transistor on, and thus turning the input to the KIM on and off, the same as we would have done if it was a proper teletype. Now I hope I haven't got any of the signals inverted. If I have, then I'm going to have to do them again with putting inverters on them. So we'll try it out and see if it works. So we want to get a 0 to 5 volts there in sync with what the transmitter is showing. So this is what we're going to do. Quite simple. We're going to take the small circuit board, put a 1K resistor on it, and then wire it up to these pins on the adapter board and plug it in and see what happens. So here's the bits we'll be needing. I've got this edge connector to plug on. I've already marked up what pins we need to connect to. What you have to be careful with these is the on the diagrams for the KIM-1, the one side is marked A to, I think it's Z, but it goes A, B, C, D, and there's some letters missing. Whereas on this one, there's actually letters written down here, and there's none of the alphabet missing, so they don't line up. That's why I've written them on here, because K on here, so the KIM K is actually pin I, T goes to P, U goes to Q, and V goes to R, so you have to be careful. And so there's 5 volts outside, 0 volts outside, and that's 21 or J. So I need to do some wire jumpers across, and this is going to go on to the bottom connector of the KIM-1. So a bit of wire to do that with. And there's a resistor that I'm going to put across this. If you open this up, got this little beastie. Focus. Now that is the same as I used on the 64 channel logic analyzer. And we're going to put the resistor between the 5 volts here and the, what does it say? It's got it down here. That should be the RX, wouldn't it? 5 volts on RX. So that pin there and that pin there, and then we connect ground, TX and RX to this connector, plus there'll be a couple of other jumpers on there that it needs, the one to tell it to do teletype here, and there's also the 0 volts you have to put on the K signal, K connect part, the K pin of the A connector to make the onboard address decoder work. And I'll also fix this on this end where the supply is, so this will just plug this in and power the whole thing up. A nice bit of shrink wrap to protect it from any shorting out. So we've just got to solder that up now. Okay, so that's that plugged in. Let's see if it'll do anything. Let's try it with putty. Alright, it's putty. We're on... Oh, which COM port are we on? I better check that. And device manager. And we're on COM3. Okay, so we want serial SPR 1200. We're on COM3. And print over, delete. And I'll get anything. I'll get anything. Press the reset button. Delete. Nothing's happening. Have we got flashy lights? No, we haven't. When I press reset on the KIM-1, the current loading changes, so I think it's resetting. Nothing on the keyboard as you'd expect. I think we'll have to start poking around with the scope. See if we're transmitting something first. Need to transmit a rub out, which I believe is delete, which is ASCII 127. Maybe I shouldn't have put that shrink sleeve on. Let me start up putty again. There's putty gone. Over there. Good. COM3. Save this as KIM-1. Rub out. There we go. Well, we're only at 100 millivolts of division. So we're just not getting the voltage on there. Oh, I'm going to have to build an amplifier. This one. So I'm coming in here, measuring at this point. Trying to generate a voltage across here. Nothing on the scope. Oh, a little bit on the scope. There we go. 0.2 of a volt. So that's that. I'm going to transmit. There's no loading on it now. All right. 5 volts. Let's get the cursor back on there. There we go. That should transmit out, which is 3.3 volt. Right, we're measuring across here and getting 22 ohms. So could it be that transistor's not working? Or we've got one of these threes bad? We might have a duff input and that's why it's not working. It's 3.3 volts. Oh, that's 3.3, sorry, ohms, and that was 3.3 ohms. Oh, that is that 330 nanofarad capacitor. What a lump. Because at this point, I decided to remove the capacitor, the diode, and the resistor so I could test them individually to see what was wrong. The resistor was 220 ohms. The diode was working fine. But that big lump of a capacitor, well, that turned out to be 3.4 ohms across it. Pretty much a total short. So I popped the other components back in, soldered them on, and I thought we'd try it out. And now this transistor is switching on and off merrily. But we're not getting any signals out. Well, not the signals that I was expecting out. So if we bring up putty now, there we go. There's putty. That should be saying KIM when I press a key. So press the reset on KIM-1 and then rub out, which is backspace. And we get all this coming up. And when I press a key, you get these three characters. A little r, capital R and F. And it should be KIM in capitals. So I'll put the oscilloscope on there and captured it. Let's just try that again. Oh. Oh. Ah, oscilloscope set wrong. Try again. There we go. That's the signal. Alright, if we bring up the cursors and we measure one of the smallest pulses, and so that's 1 bit, and that is 849 microseconds. That's, which means we're running at 1200 baud. This is the signal coming out. Right, so we're getting gobbledygook come back. I reckon that is correct. I think the bits are inverted. So I think I'll have to build an inverter of some sort. Okay, so I've built this with another one of those serial ports. And what I've done is this is the same resistor as what we'd put on the original board. And this IC is a 7404. It's a hex inverter. So what I'm doing is taking the signal, instead of feeding it straight into the RX, I'm taking the inverted signal. If we bring that up on the other screen, there we go, we've got putty running, and hit a key, and we get sense out of it. If we reset to KIM-1 again, and we get KIM-1. So the transmit is fine. It was just the receive that needed inverting. I might do it with a transistor rather than a chip. Well, as we found out, this circuit doesn't work properly. The RX signal is inverted. I had built on the little red board an inverter using an IC, the 7404, just to invert the signal here. Everything came to life and started working. But just to make things a bit smaller and simpler, I've decided to use this circuit instead. Now the signal from the KIM-1 comes in here. It's got its 5-volt supply through a resistor. And we know the KIM-1 is just another transistor switching to 0 volts. So this is the signal that we were seeing into the RX to start with. But now that comes via this resistor into the base of this transistor, which is again just switches down to 0 volts. So this is basically a NOT gate. So whatever's here gets inverted there and gets fed out to the RX pen on the USB serial adapter. And now if we just take a look at that, if I'm getting close on it, just try and get it in focus. Come on. Let's put my hand there. There we go. Just see it's 3 resistors and a transistor. and that just feeds back into the edge connector there. Same as before. Still got that capacitor disconnected. A bit of trouble sourcing new one of those. It's a bit of a difficult one to find. But it's not desperate that we use it, it's just for noise immunity. Now if we just plug this in, get all our flashing lights coming on. And we turn the KIM on as well. And press the reset button. We run up putty now. We go back to here. Oh. Let's get the right screen. There we go. Putty always opens on the wrong screen. Backspace, and there we go. So if we now type in 17F7, a space, so we go to that address, we type in FF, decimal place, we write FF into that location, so we now point at the next one. Then we type in 1F, the decimal point. That's just written 1FFF into that memory location. We now point it at 1C00, just space. Now press Q. It's now sending to the paper tape punch and here all the bytes from 1C00 to 1FFF. So that should be all of the right chip 002's memory. So this is basically the monitor ROM, one of the ROMs anyhow. So you could save all that, and you could send it back again if you wanted. As you can see, all working nicely now. I'll put some heat shrink over that little board to tidy it up. So we're all good to go now. So hopefully I'll see you in the next episode, where we'll be building some more plug-in boards to expand the system and possibly run some other software on it. So don't forget to like and subscribe, and I hope to see you in the next episode.